Hello everyone. So this is the first time I'm traveling abroad from the India and going somewhere. So it's the first time talking as well outside the country, and talking about concurrency showdown. So it's all about like how we can efficiently say. You can see here like we are actually wearing some cross I would say like ideologies in here. So for whatever debate sort of things can happen. So myself, Vishwajeetsingh Desurkar, I know it's quite a long name, but as he's called me like a small Vishwa, so you can call me in that after while interacting as well. Yeah.
And my name is Ishani, small name already. And yeah, we're from India, as he said, first time in Australia. Yeah, the weather here is quite nice, is all I can say. We actually, both of us, belong to very different culture in India. I am from Ahmedabad, and he's from Pune. So
Yeah, talking about Pune, so I know like India is considered as diversified and all those things. I will just give an example, like we are not that far apart, like some 400, 500 kilometers, but the cultural differences are so much that even from languages to all over, the ideologies about things are completely different. This is a Pune, so you can see here like we are nearer to the western side of the western coast, near to Mumbai. And you can see here like it's a perfect mix of all, like you can see some cultural nuances in which there are forts, who were dated back to like 1600s, 1700s. And then there are some continuously cultural fests and continuously going on. There is a big IT hub there. It is also considered as the Oxford of East because it has like some more than 150 colleges within a single city. So you can consider that that's a level of like, that's a big mix of all sort of things. Yeah, talking about Ahmedabad.
yeah, talking about Ahmedabad, if you are a cricket fans, you already know the World Cup happening and Australia won. But yeah, it was in Ahmedabad, the final. And yeah, we're also big on culture. There's Navratri. It's a very colorful festival for 9 nights. And yeah, heritage, it's a World Heritage City. So yeah, that's a small thing about India from which we belong.
Let's moving on, yeah, to the topic.
Okay, so concurrency showdown brings us to the big old question, what is concurrency, what is parallelism? Looking at this image, how many of you think this is concurrency? Or parallelism? So, points for parallelism? Points for concurrency? Okay.
Are confused.
So, okay, we'll talk about what is concurrency. What is concurrency? Concurrency is multiple processes or tasks executing at the same time. How is it implemented in programming? It has shared memory or data between all the tasks or processes that it works. Then second main thing is that it coordinates between the resources so that all the processes work simultaneously at the same time. And why is it important? It is important because it maximizes performances. It also, if we use it efficiently, it increases the scalability. Chances of scalability, I would say. So yeah, that's about concurrency.
Yeah, so I would say I'm Batman. So starting about this thing and talking about threads. So I'm marking like a Batman sort of ideology for threads since it's old school and all sort of things. So what are threads? Threads are lightweight processes. A simple definition. You have to complicate all those sort of things. But diagrammatically, you can see here like multithreading is nothing but like we are spawning multiple workers, I would say, to maximize the performance of the system. Then how we can utilize the multi-core systems and all that you can simply identify. Let's just take example of a code. So this is a basic example in which we are mapping all the search results from result set one by one sequentially, and it will take like certain specified time, I would say like a normal sequential flow and all. So we can just modify that in a simple way to optimize the performance using multicore. Just you can just convert this into a threaded example in which there's always going to be a new thread getting spawned for every new result set that is going to be fetched out from the data. Yeah. But I know like it won't guarantee like the limitations of number of threads and all those things. I'm just giving a random basic example here. So talking about the next thing, I would say like GIL or a global interpreter lock. So what it does actually, from this diagram you can understand this thing. In multi-threading, we are spawning multiple threads to optimize the CPU performances and all. But global interpreter lock allows only one thread to get the resources and to perform all those tasks. So in a way, it's kind of prohibiting the purpose that we are having here. It kind of kind of defeating all those things, like are we going to achieve that much of a performance enhancement? Or I would say like some sort of parallelism, since we are discussing like both are the similar sort of stuffs. Yeah.
So yeah, as you said, he's Batman and he's defending threads. But I would say, what are the limitations of threads? The basic definition of thread says that it actually requires OS to schedule and to actually work concurrently. So here I'm presenting fibers, Superman. But yeah, so what are fibers? Fibers are even more lightweight processes, or lightweight threads, I would say. And few pointers about fibers is that it is one of the primitive concurrencies in Ruby. It actually executes within a thread. So, and one of the key points is that it handles the asynchronous I/O operations without blocking the entire thread. And since it does not have a shared memory, the memory overhead is very low. And one thing that fibers were introduced earlier in Ruby 1.9, but it was not so popular at that time. But when it was rewritten in Ruby 3.0, and it actually, Ruby 3.0 introduces fiber scheduler, which uses scheduling via fibers, so that execution of multiple fibers for scheduling tasks. So that's how it became popular. And to move on to how fibers actually implemented, this is a code snippet of how fibers would work. The key point here to notice is fiber.yield, and then there is fiber.resume. So one thing about fiber is that we are in control, so programmers are in control of concurrency, or starting or executing the fibers, or pausing or resuming the fibers. So fiber.yield is the method that is used to actually pause the fibers, and fiber.resume is actually used to start the fibers. So we as a developers are in control of how concurrently or how or when the fibers would stop or start.
Okay, but are we here for just discussing these things, or are you here for fight?
Yeah. Let's
Let's start with the round one. Yeah? Yeah, let's see who can win. Starting.
Yeah. So round one, race conditions. All multi-threaded programming starts with this. So yeah, race conditions. What is race conditions? Race condition, it actually bothers a lot of programmers, because it is actually, we don't predict the outcome. We don't know how it will work or how the outcome would be, since we don't know which thread is executing at which time and which will not. So yeah, synchronization miss is a big thing. Do you think threads actually handle it properly? I don't think so.
Yeah, it's quite a personal for me. Like while roasting as well, I would say like some debating as well. You are using a Batman meme to roast Batman. So.
Yeah.
So talking about that, you said, or the race condition sort of scenarios and all those things. I know, but this is for naive programmers. Might be you are the one. So talking about that, you can easily handle these sort of cases. Let's take one example, like in which it's a simple example in which there's a bank account class. We are just initializing a balance, and there's a method which is actually deposits balance in the balance, like and we can have multiple threads just simultaneously depositing in that particular balance. So this is a pretty simple example in which race condition, there are more chances of getting into a race condition. But to solve that thing, we just need to do smaller changes that will easily able to handle it. Earlier I said there is a locks, the GIL, right? So what you can do, there is one lock you can easily apply. This is a mutex lock, which you can simply use with, like, you can just initialize the lock. Then you can use that to synchronize, so that at a particular time only a single thread will have access to it. But what about fibers? Will they able to handle this sort of issues?
Let me tell you, my friend, fibers does not have race conditions. Why? Simply because A, we are in control. We as a programmers, we have to yield control voluntarily. So yeah, and it's a single-threaded implementation. So fiber, the scheduler will never, preemptively have multiple fibers multiple threads running at the same time. So in each thread, only one fiber gets executed, so no race conditions.
Okay, so end of round one. What do you guys think? Who won, a thread or fiber?
How many for fibers?
Yeah. Okay.
How many for threads? I would say fibers win.
Fibers kind of won that thing, but okay.
Moving on.
To the next round. We are not done yet. unless you won. Yeah. So talking about round 2, let's talk about deadlocks. I know the universe got changed, some Spider-Man's in here, but it is a pretty good example to just summarize what deadlocks are, right? So what are deadlocks? The mutual blocking where processes just wait for each other, like indefinitely they're waiting each other to complete their task. And this is a simple definition of a deadlock. Before starting, I'm not a naive programmer, so I'm first going to address like how it get handled in threads, and then I can talk about it. Yeah. So talking about how to avoid deadlocks in threads. So pretty much like, as I earlier stated, locks. So but in locks as well, we should maintain that specific order because we don't want like randomly, there are few only getting the benefit of the randomness and always getting the locks and getting the resources to complete the thing. So we should have specific order in it. Secondly, there should not be the case where there is a thread and which is acquiring the lock and not releasing it because it's continuously getting executed into loops or something. So we should set certain timeouts to it. Third is use thread-safe data structures, but it should not be the case like you have done all sort of great programming and done like all sort of like gateway, all sort of checks perform, and at the end the issue is with the data structures that you're using. So that should be one of the key point in this case. And last one is maintaining synchronization. That's what we had done in the last example with the race condition as well. But since we are able to handle these sort of things in threads, what about fibers? What if Superman gets out of the control and started killing everybody? You won't stop unless everybody's dead. Like resources get corrupted, right?
Yeah, right. So avoiding deadlocks in fiber, good question. First of all, I would like to say that scheduler would never preempt a deadlock since it's not in control. We are in control. But yeah, sometimes we do have to control our own superheroes in order to maintain peace and goodwill. But yeah, fibers need explicit yield. So I would say a programmer's responsibility is there to actually avoid deadlocks. But yeah, you're right. Sometimes we do need.
Yeah, so you can see the example here, like just like Superman is getting controlled or managed by the dark side. It's like villain is controlling the superhero here. And similar case happens here because if anybody forgets to have explicitly call the yield, then you're screwed, right? But in threads, at least there is certain chances that you will get saved out of it from the deadlocks and other situations. Yeah, this is round 2. What do you guys think? Who won this one? Threads or fibers?
People for threads. Yeah.
Yeah,
Fibers.
it's okay. So it's 1-1.
Yeah,
Let's
it's a
move on.
tie.
Yeah. Let's move on to the next one. Yeah.
Oh, third point, interrupts. Everybody loves it. No, not
Nobody loves
really. But yeah, handling interrupts in fibers. Fibers, I would say, are less susceptible for to interrupts because since I mentioned it multiple times, we are in control. We are the controller of the flow or the execution. So yeah, I would say fiber does handle interrupt sort of, kind of, if we do properly.
Okay.
But this is, I think, how threads handle interrupts. No, every solution to Batman's problem is money.
Not really. Yeah, but most of the time that's the solution request. Like in DC universe as well, whenever there is an issue.
Just have more threads.
Yeah, you can have more resources. Yeah, but talking about the threads as well, there are certain, I would say, like the guideline, certain sort of checklist you can maintain, like what sort of things you can do to handle interrupts. There are certain, like, you can use flags. Whenever, like, using that, you can understand, like, at which thread or something there are the interrupts are getting into the picture. Secondly, you can maintain timeouts. Earlier as well, I mentioned, like, you have to maintain the timeouts because you don't want to trust, like, threads go again and going on to utilize the resource again. Third one is you can use a method, thread all kill. Directly, you can kill that particular thread and then you can start. Yeah, sorry.
Killing the
Yeah, and then the last one is to maintain queues based to maintain the priorities, right? Yeah, that's.
Okay, end of round 3. What do you think? Who won? Points for fibers? Points for threads?
Yeah, so.
Yeah, kind of, sort of. I think we need a lightning round to solve the problem.
Yeah, let's get ready for the lightning round. Yeah, let's start. Yeah.
Oh, okay. So my problems with threads are it's difficult to debug. it's not really a programmer-friendly thing, I would say, as Batman says. I'm not really a people person, but because threads are very complex to debug, I would say. Once a thread breaks on production, how would you find where things did go wrong? We'll just scratch your heads and.
Yeah, fair enough. So, but talking about fibers. Fibers do not support native parallelism. Then what are you doing? Like, what it's actually getting used for? Like, if it doesn't support the native parallelism, that is just like virtually giving a fact, just like fooling the developer that is giving a parallel. Yeah.
Okay. Okay, he mentioned GIL multiple times, but I would say GIL, the thing that you mentioned, is the one problem that we have for concurrency, isn't it? It only allows one thread at a time.
Yeah.
How is it truly concurrent then?
Okay. Yeah, great. So talking about fibers, they're not useful for compute for heavy operations. Like you can see, like the Superman just forget about all things and started doing this sort of heavy lifting. In this case, yeah. So, but if it doesn't get used for heavy operations, then how would you sure, like, because you need multiple, like I would say, like concurrent processes or parallelism when there are complex tasks, you want to achieve it faster. And if it doesn't it's not useful for heavy operations, then what's the use of it?
Yeah, fair. Next up, threads are not good at optimizing CPU utilization. We already know that. The GIL, the diagram that you showed already before. Even if the CPU has multiple core CPUs, threads are not good at optimizing, I would say. So why have a cape when you can fly?
Oh. Okay. Fibers always need explicit coordination, like, because tactically, if you're just flying over all the cities, I would say you don't actually know where the problems are. So Superman, or I would say the fibers need explicit coordination from somebody else, like in this case threads. Yeah.
Yeah, fair enough. But again, shared memory. Threads have multiple sharing, multiple threads share memory. Wouldn't it often lead to memory leaks or data corruptions?
It might be, but that's part, yeah.
Not might be, at very low might be.
Okay, talking about, like, since she's mentioning all memory-related stuffs and all those things, what about this thing? Fiber doesn't have a shared memory. Even if it doesn't have a power, then there will be no issues. Again, yeah. Yeah, but like talking about this lightning round and going ahead again and again, like what sort of issues have with threads and fibers? So what's the solution to actually if there is somebody like a doomsday where both need to work? Yeah.
Talking about all the limitations, I think we both fibers and threads have enough of it. Maybe we can leverage that and kind of try to work together.
Yeah, from enemies we can be the frenemies.
Yeah.
And help each other. Yeah, just like everyone is helping Batman to ride. Yeah, let's take an example like how we can leverage advantages of both to solve a problem.
Best of both worlds.
Yeah.
So yeah, this is one example. This is a image processing service where a user can actually enter a URL and enter what type of transformation he wants on that image. And let's see how we implemented it. So yeah, that's a pretty big code, but breaking it down, we used fibers for fetching the data from the URL. Why? Because it's good at asynchronous input-output calls, I would say. So yeah, that's fibers, that set schedulers for fibers. Next up, threads. Threads, as I said, it's good for CPU-bound operations. So we are using it to actually perform the transformations that we need on those images. And yeah, next up, we'll wait for the fibers to finish. And that's about it. I think we built a good...
Yeah, we built a great team.
Yeah, we make a
So talking about these things, like although we find a way to work together, but are we both enough for all those problems? Like, let's say, for example, threads and fibers are enough for us to solve all the problems? I think no. So what's next? A Justice League, right? So Batman and Superman alone can't solve all those things, like if there are certain villains to fight. So what are other superheroes that we got that somebody can explore as well? Talking about one, Raptors. So we all know that I was talking a lot about GIL and its limitations about certain things. So Raptor actually bypasses GILs to get parallelism out of Ruby, and it solves that problem where there is only one core getting utilized, or few cores are getting utilized. So Raptors is one of them. Talking about other superheroes, yeah.
Yeah, as I mentioned fibers earlier, there are few gems that we can explore that is already built on top of fibers. First is async. Async is a very good gem. It's built on fibers. It actually leverages the I/O and the asynchronous call and all. And the other things are async HTTP and async I/O. Both of them are built on top of async, which leverages the HTTP client server requests, and the async I/O is used for the asynchronous input-output calls. And the creator of async also built Falcon. Falcon is a server, actually, which is built on top of fibers. And yeah, it uses all the async HTTP, async I/O to actually work. And he was trying to make the deployment easy for fibers or for asynchronous programming rather than Puma or other HTTP services. So yeah, you can explore and check it out. If you guys want.
You can build your own Justice League and solve most of the problems. Yeah, that's it. And before closing, let's just talk about Josh. It's not Josh, it's Josh. So Josh stands for, it's a Hindi word, stands for passion. And you might have heard like some reels or something, or sort of like there is actually an acronym everybody calls in army or something, like how's the Josh, and everybody calls her hi sir. So that's kind of our goal sort of in all those things. I have given some few photos in it, like which actually depicts like how we are invested in Ruby specifically, because you can see Ruby in logo. From last 16 years, primarily when both of the co-founders wanted to start something out, they think, let's build something. We will be the best of best Ruby developers coming, obviously the company. And as I mentioned, like few events in here, like there are RubyCon, there are GopherCon, there are Rails Girls that we organize. And even you can see like at the start of our office gate, there is a Ruby logo, because that's how we endorse that thing, or we say love. And one of the pictures shows cricket team as well, because why I mentioned that thing, Joe started because of that thing, cricket. Because both co-founders never worked together before starting the company. They were just a part of the same organization, and they were part of the same cricket team. That's how they met. And then the first employee also got hired on a basketball court, not on actually the office space or something. So that's how it started. And from that moment to till this moment, I would say like I would say that the longest running employees, like from 10 years, 12 years, who are with Josh, most of them are connected through sports. And that's one of the key factors of Josh that I would say like differentiate from others. Yeah, so that's it from my side. You guys can connect us, or those are X handle, sorry. Yeah. So you guys can connect us or X or any other platform as well. And if you are interested into connecting to discuss this like Justice League and how we can build it ahead to make it a more fearful one. Thank you.
Yeah, thank you guys.